Hi, in this video we're going to go through a quick review of exponential properties. So for all of these properties, it's important to note that we're going to let a and b be real numbers and m and n be integers, and that's where these properties hold for. So the first property we're looking at is the product property. The product property tells us that if I have two exponents with the same base, so in this case the base is a, and I'm multiplying exponents with the same base, then it's essentially adding the exponents. And so as you can see here, I'm multiplying a to the m to a to the n, and I can simplify that to a raised to the m plus n. The other two properties we're going to look at is the power property. The power property tells us that if I raise a power, raise an exponent to an exponent, that's equivalent of multiplying those exponents together, as you see here. The power of a product property shows us that if I have a product of two numbers, a and b, raised to some exponent, that exponent essentially gets put to both the base of a and b. So for instance, a times b raised to m is equivalent to a raised to m times b raised to m. The next two that we're going to look at is the quotient property. The quotient property tells us if I'm dividing exponential expressions with the same base, that's equivalent of subtracting the exponents. As we see here, for instance, a to the m divided by a to the n is equal to a raised to the m minus n. Likewise, if I do the power of a quotient, kind of like with the power of a product, if I'm dividing something and then I want to raise whatever I'm dividing to an exponent, that's like tacking that exponent to the base of a and b. The next one we're going to look at is a negative exponent property. And a negative exponent property tells us that if you have a negative exponent, that is equivalent of the reciprocal of that expression. So a raised to a negative m is equal to 1 over a to the m. And the last one we're going to look at is the zero exponent property. Anything raised to 0 is equivalent to 1. So let's look at some examples here. These examples are a little more complicated, and so I picked them because they involve multiple steps of the different properties so that we can see. It's important to take these and do the properties one at a time. Don't try to do 3 all at the same time. We want to just look and see what we're doing. So the very first thing is I look inside my parentheses, and since I can't simplify anything inside parentheses, I then move outside the parentheses, and I have an exponent. So now I have the power of a quotient. So how I would simplify this is y raised to the second raised to a negative 2 is equivalent of multiplying these two exponents together. So 2 times negative 2 would give me a negative 4. 3 raised to a negative 2. It's important to note that it's every term inside the parentheses, and that includes variables and coefficients. And then x raised to a negative 2. So after I do this, I can simplify further using the product property. Y raised to the 7th times this quotient is, since y and y are the same base. Now, it's important to note, if I could have simplified in here, I would have. However, but since these are the same base, I can add the exponents by the product property. So 7 plus negative 4 would give me 3. And then simplify. Since I have negative exponents in the denominator, what would happen is I would essentially take the reciprocal. So if this is 1/3 to the second, or 1 over 3 to the second, it's now going to be 3 raised to the second, which is just 9. So I have 9 to the second, y to the third, as my simplified expression. The next example is, again, I'm going to look at what's in the parentheses. If I can simplify, I can't. However, I can bring this negative 1 to both of the base x and 1, or I'm sorry, x and y. And then using the quotient property, I can subtract these exponents. So negative 1 minus 4 would give me a negative 5. and since it's negative, I'm going to have that in the denominator. Negative 3 minus a negative 1 is a negative 2. Since it's negative, I'm going to have it in the denominator. And then 2. So if I were to simplify it over here, in case someone lost me here, that would be like saying 1/2 x to the negative 5th y to the negative 2nd, which then simplifies to the x to the 5th and y to the 2nd in the denominator. We're going to use these properties in these type of combinations to simplify more complex looking expressions so that we can eventually get to a point of solving exponential equations. Thanks for watching.